Hello everyone, I just wanted to take a little bit of time here to go over a couple of different things about the way that we communicate latitude and longitude, about the way we communicate coordinates about the planet. I hope that a lot of this is review for you, but it's important to go over just in case, one, you didn't already have this information, and two, because sometimes GIS software packages, or actually rather frequently GIS software packages, do things that are different from the standard way of doing things. So it's important to understand what's going on so that we can compare and contrast what certain software packages give us. So let's go ahead and do that now. Let me look at, let's give it as an example here, some coordinates, and maybe we have 32 degrees north and, I don't know, 96 degrees east. And this is a perfectly acceptable set of coordinates here. Note that here we have, this is our latitude. And this is given first. Okay, and this is the longitude. And this is given second. So you don't change that up. We give latitude first, we give our direction north or south of the equator first, and then we give our direction east or west of the prime meridian. And of course you can see we have the number here, the number of degrees, we have the little degree symbol, then we use either north or south, or east or west, an E or a W or an N or an S to indicate our direction. What if, we do know that there are 90 degrees between the equator and the North Pole, and between the equator and the South Pole, and then 180 degrees between the prime meridian and the international date line, either way that you go. What if you need to give a location in more detail than just reporting to the nearest degree? Well, we can do that. Maybe you've heard of what we call DMS notation. And this is a very common, it's sort of the official way of giving latitude and longitude. And this is DMS notation, and it stands for degrees, minutes, seconds. DMS format. Because for every 1 degree that you have, every 1 degree can be broken into 60 minutes. And every minute can be broken into 60 seconds. So when we're giving latitude and longitude in DMS notation, we're using not a base 10 system, not a decimal system like you may or probably are most familiar with, but we're actually using a base 60 system. So this is one of only a couple of places where a base 60 system has kind of continued into the world today. Probably a base 60 system, 60 of one thing becoming 1 of the next, is probably a bit strange to you. We're used to 10 of one thing becoming next, or 1 of the next thing when we count using a decimal system. Base 60 is a little bit stranger, but the Babylonians, the ancient Babylonians, used a base 60 system when they were counting. And so this is one place where it sort of endures. Of course, you probably recognize minutes and seconds from time. And of course, we did talk about the relationship that longitude has with time. But we do use a base 60 setup in time as well, because we're used to having 60 seconds in a minute of time and then 60 minutes in an hour of time. So we think about base 60 there. But this is another situation where we're talking about minutes and seconds, but this time we're talking about divisions of degrees, this angular coordinate system, and we're base 60. So 60 minutes to 1 degree, 60 seconds to 1 minute. And so if you want to get more specific than this, and you're using DMS notation, you might give coordinates that look like this. Okay, 32 degrees, 45 minutes, 15 seconds north. So we still use the degree symbol right here for degrees, but then this is our symbol for minutes, and this is our symbol for seconds. So 32 degrees, 45 minutes, 15 seconds north. And we could do the same thing over here with 96 degrees, 13 minutes and 57 seconds east. Okay, so chopping up the next degree here into 60 minutes, we've got 45 of them. Chop up 1 minute, the next minute into 60 seconds. We've got another 15 of them, and so forth. And then we've got minutes and seconds over here in the longitude as well. So this is a very common way to give latitude and longitude, and it is read just like that: 32 degrees, 45 minutes, 15 seconds north, 96 degrees, 13 minutes, 57 seconds east. And that's the way that we give our coordinates. Or this is certainly my preferred way of giving coordinates. I think that this is the way that we would certainly give them when we're writing them out formally on a map and so forth. And so it's very important to get familiar with this notation. This notation does, however, contrast with something called DD notation, which you also see. And DD notation, that stands for decimal degrees. So rather than this DD right there, so rather than this formal system that uses degrees, minutes, and seconds, some people do want to talk about latitude and longitude as if you were going to break a degree into the decimal system and just use a decimal. So you might think, oh, well, if you see something that looks like this, 32.2 degrees north and 96.8 degrees east. Well, that looks like you would expect a decimal to look right here. This is in decimal degree notation, DD notation. So this just means, just like the decimal system would, that we have another 2/10 of a degree here, and we have 8/10 of a degree right here. You can give latitude and longitude like this. It's sort of a bit more common now that we have the computer systems that do this. But notice that latitude is still coming first. This is still latitude over here. And this is still longitude over here. It's just that we're using fractions, decimal fractions of the degree, rather than breaking things out into minutes and seconds. It's important to be able to convert between these two. So I want to show you how to convert between decimal degree and degrees, minutes, seconds format so that you know what the procedure is if you need to do this. And you very well might, because you have all kinds of coordinates that you may need to get into a GIS system, and sometimes they may be in decimal degree format, sometimes they may be in decimal degree or degrees, minutes, second format, and you may need to convert one to another in order to get it into a software program. And so it's at least important to understand how to do this conversion. So let's take a look at that now. Let's look at something rather easy first. I suppose we'll start with just keep the 32 degrees north. Let's say we're at 32 degrees north, or actually, let's get rid of north right here. 32 degrees, 30 minutes north. And then maybe we're at 96 degrees, 30 minutes east. How can we convert this to DD? So this is certainly in DMS format. It's just that I don't have seconds here. I have degrees, I have minutes, but maybe this is precise as I need to be, or can be, and so I just leave it to minutes. I don't break it down into seconds. Remember that 1 degree is equal to 60 minutes. So this should be a very easy conversion to do. Shouldn't need a calculator or anything like that. If 1 degree is 60 minutes and I've got 30 minutes right here, and I got 30 minutes right here, then what I have is half of a degree. So this is 32 degrees, 32.5 degrees north, and then 96.5 degrees east. Because 30 is half of 60, I know that I'm half a degree. And this is decimal degree format, DD format. So what's really the procedure for doing any type of conversion from DMS format to DD format? Well, if I have something that's not quite so obvious, if I have 32 degrees and 40, I don't know, we'll just say 47 minutes north, and I got 96 degrees, 18 minutes east. This is decimal degree format. Excuse me, this is DMS format. How am I going to convert this into DD format? Well, basically the procedure is going to be that the degrees remain my whole number, so I'm going to say 32, but what's point? Well, I'm going to take 47 here and I'm going to divide it by 60 because I want to know what a percentage basically it is out of 60. So 47 divided by 60, that is equal to 783 repeating degrees north. And then over here, 18 divided by 60. Okay, that's 0.3. So 96.3 degrees east. Okay, and now we are in decimal degree, DD format. I'll do one with seconds just to show you the conversion. So if I've got 32 degrees, 46 minutes, and let's say 20 seconds north, and then over here 96 degrees, 18 minutes, 40 seconds east. This is degrees, minutes, second format. And not only, of course, does 1 degree equal 60 minutes, but 1 minute is equal to 60 seconds. Okay, now this one is a little bit harder because I've got the seconds in there, so there's going to be an extra step, but it's not going to be too hard. Well, the first thing I'm going to do is I'm just going to keep the whole number. So this is 32 over here, and I need to come up with what's going to be over here in the decimal place. Well, 46, I'm just going to take what I've got up here. So 46, we're going to do that just the way that we had done it before. It makes sense that there are 60 minutes per degree. So I'm going to divide 46 by 60. And when I do that, I'm going to get 0.76 repeating. But now this over here for the 20 seconds, I'm going to have to divide that by a number as well, but the number I'm going to have to divide that by is 3,600. Now, why is that? Well, it's because I want to know how many seconds are there per degree. How many seconds are there per degree? And if there are 60 minutes per degree, 60 seconds per minute, then if I take 60 and I multiply it by 60, I should get the number of seconds in a degree, right? Well, and what happens when you multiply 60 by 60? You get 3,600. So there are 3,600 seconds per degree. So if you want to know, in this case, what fraction of a degree, which is precisely what we want to know, what fraction of a degree is 20 seconds? If I take 20 seconds and I divide that by the number of seconds in a whole degree, 20 divided by 3,600, I get 0.005 repeating. Okay? So what I do now is I add all of these together. I've got the whole number over here, 32, that's going to stay the same, but then I'm going to add to it 0.76 to add in my fractional minutes, and then I'm going to add in 0.005, repeating, in order to add in my fractional seconds. So 32 plus 0.76 repeating plus 0.005 repeating, that will give me the fraction that I need in order to come up with how many decimal degrees that is. So plus 0.766666 plus 32. So that should give me 32.772 approximately. And this is still degrees. This is the fractional number of degrees north right there. So 47 minutes 20 seconds is equal to 0.772 when you do the math out. And that does make sense if we said that there are 60 minutes per degree. 30 minutes would be 1/2 of a degree. 46 minutes is obviously more than half of a degree. In fact, it's more than 3/4 of a degree. So 0.772 when you add in the seconds, that seems at least like it's a perfectly reasonable answer, and I think it's right. So let's go ahead and repeat that over here. I know that I've got 96. I'm going to keep the whole number right here, but now I need to know 18 divided by 60, and this is going to give me, in order to take care of the minutes right there, I'm also going to have to take 40 and divide it by 3,600, and that's going to give me the fraction of a degree that those seconds are. 18 divided by 60 is 0.3. We actually did that one already. Now 40 divided by 3,600 is equal to 0.01 repeating. So now I'm going to add all of that together, and it looks like I would get 96.31 repeating degrees east. So 32.772 degrees north, 96.31 degrees east. This is decimal degree format. So now we can go from degrees, minutes, seconds notation to decimal degree format by hand if we need to. And this may be something that you need to do. Even if you don't have to calculate a whole bunch of them out by hand, well, it'd be very helpful to be able to write out an equation in Excel or in some other spreadsheet program in order to create a formula to calculate a large table in order to do conversions of a whole bunch of coordinates very quickly. Or even if you're getting into Python scripting and so forth in a more advanced sort of application for GIS, you may need to write part of a script or an application that will take care of this for you and do these conversions automatically in order to move you on to the next step. So this is important to do. We can go the other way. Let's take a look at going the other way. That was going from degrees, minutes, seconds to decimal degrees, but we can go from decimal degrees. Maybe we've got 32.75 degrees. Let's go south this time, and then 102.15 degrees will go west this time. So this is definitely in DD format. This is decimal degree format. We are wondering, what is this in DMS format, degrees, minutes, seconds? Well, this is not so hard. It's just going to be moving backwards through the process that we did before. Well, as we did before, the whole numbers begin the same. So this has got 32 degrees south over here. So 32 degrees is going to be my number of degrees. Now I've got this 0.75 degree, right? How many minutes is 0.75 degrees? Well, if I multiply 0.75 times 60, I will get the number of minutes that is. So if you can easily see that if I were to take 0.75 and multiply it by 60, I'm going to get 45. I get a nice even number here. So that's 45 minutes. 32 degrees, 45 minutes south. Over here, I'm going to do the same thing. 102, excuse me, I don't need the point right there. This is just going to be 102 degrees. 102 degrees. How many minutes? Well, 0.15 times 60. And as you can tell, if I take 0.15 and I multiply by 60, I get 9. So this is 9 minutes. 9 minutes west. And this is DMS format. Let's do one with the seconds involved, so we have one more step to do. Let's say that instead, maybe we had 32.2472 degrees. We'll make it south again, and then maybe we've got 102 point, I don't know, let's say 0.23 degrees west. So here are our coordinates. This is definitely decimal degree format. Let's convert. Well, I'm going to pull down my whole numbers. So I got 32 degrees here. Now what I'm going to do is I'm going to multiply 0.2472 times 60. And let's see what we get when we do that. 0.2472 times 60. That gives me 14.832. And that's the number of minutes. Interesting. I have a decimal number still. See, I didn't end up with a decimal number up here. I ended up with something nice and neat. Well, I end up with a decimal number down here. That should tell you that this is the number of minutes, 14 over here. But then I still have some number of seconds left over because I have numbers behind in the decimal place. So what I'm going to do is I'm going to move the whole number up. So I say 14, except for this is minutes right here. And then I'm going to take 0.832 and I'm going to multiply it by 60 again because there are 60 seconds in a minute. 0.832 times 60, that equals 49.92. And so you have a couple, these are the seconds right here. You have a couple of options right here. Maybe we could just round it off depending on the application that we've got to say that's going to be 50 seconds south, or sometimes you might have the seconds reported in with a decimal number depending on the precision, depending upon the accuracy, depending on the number of significant digits and so forth that you are reporting your coordinates to. So we took the whole number, brought it down, multiplied the decimal number by 60 to find out some number of minutes. We found out we had 14 whole minutes plus some fractional part of a minute, and then multiplied that to get exactly how many seconds that there were left, and which is approximately 50 seconds. Let's go ahead and repeat over here. I'm going to bring down my 102 degrees. I'm going to take 0.23, let's see what we get, times 60. And let's see what we get when we do that. 60 times 0.23, that equals 13.8. And this is talking about our minutes. I'm going to take the whole number, I'm going to move it up. So I've got 13 minutes. And then I've got the remainder here, 0.8 times 60. And that is equal to 48. Oh, that one came up nice and neat. So 48 seconds west. This was west. And this is DMS notation. So there we go. We have some information about how we typically communicate latitude and longitude, and that is in DMS, degrees, minutes, seconds format. Sometimes you see latitude and longitude communicated in terms of decimal degrees, and you can do that as well. You still give latitude first, longitude second, and we can convert back and forth between DMS and DD using the method that we were just shown right here. So, all right, very handy thing to be able to do, and handy thing to be able to understand and conceptualize if you are in geography or GIS.